Today we will discuss very innovative topic, that is RF absorbers being used to harvest radio frequency energy, which will be used to drive low power devices. That can be a digital watch, environmental sensors, health sensors, and many other IoT devices. The topic is innovative and new. Very less research work has been done so far on this topic. In this area, what we expect that as far as applications are concerned, we will be able to get 1 volt to 4 volt with 1 milliampere of current. Here we have developed a hardware simulations. The simulations has been performed using CST, ADS, and then based on Schottky diodes as well as CMOS rectifier, a hybrid approach has been developed to harvest radio frequency energy and convert into low power DC using voltage doubler, voltage quadrupler, and a rectifier integrated with impedance matching network. Here we will like to focus one more thing, that we will develop reconfigurable integrated impedance matching network, which is totally new area of the research. Reason being, there is a variation in the load as well as there is a variation in the input received power. To have compensated effect or a integrated approach has been developed so that the variation in load can be utilized as well as the fluctuation in received power is also being utilized. Also, the hybrid approach being used so that when the power received is very low, we will be operating at CMOS circuits. When the power is sufficient to drive Schottky diodes, we will be using a Schottky diode approach for rectification of this radio frequency energy to harvest the DC voltages to drive the IoT devices, low power digital watch, the low power sensors which are being used to monitor environment as well as health care facilities. So the research outcome will be very advantageous as far as societal impact is concerned. For this, we will be developing first absorber, and the absorber will be having the modes, the T mode, TM modes, and these modes will be multiple modes, and these modes will drive us to get better absorbance on the fundamental mode as well as on higher order mode. Then we will be able to apply these resonant modes to have multiple operations. That is, the input stages may have multiple rectifiers in cascade, and then parallel output can be amalgamated. Similarly, the new concept of having multi-band antennas, multi-band absorbers can also be integrated to get better results on DC output voltage. For this, we will be measuring few parameters such as the absorption parameter, and the absorption parameter will be measured at T mode, TM mode, the circular polarization which can be LSCP, RSCP. Then it can be determined whether the incidence waves are normal or these are oblique. These normal incident waves and oblique incident waves will be taken care so that a wide band angle is being formed as well as the polarization insensitivity is being approached in conjunction with the incidence angle approach. And these are the new areas, that how can we increase the incidence angle as well as how can we make these absorbers as polarization insensitive. The major part of this particular topic will be how can we get better efficiency or how can we get better conversion efficiency? That can be the incident radio waves which are being incident normally or obliquely is being considered at right part of absorption, or the absorption coefficient must be constant. So to have that, we need to focus on two areas. One is that the incidence or input power may be fluctuating, but you must be able to get outcome of these fluctuating incidence powers as constant, and that can be dealt with if we integrate the impedance matching network in reconfigurable pattern. And similarly, we can also overcome the problem of low rectification efficiency by integrating the rectification circuits into cascade or in parallel, or the combination of cascade and parallel. So these are the few major areas where more research is required. But ultimately, the objective of this particular research will be that we should be able to harvest the ambient energy for usable DC power for operating the low power devices. This all in the next lecture we will talk about detailed description in the circuit diagram. Thank you.